Hello everyone, my name is Ryan Wibawa. I'm a software engineer and I found a new hobby with the Raspberry Pico board. So what I did was going to the YouTube and then find a resource from Scott at the low level learning channel. This is one of the good resource on learning how to program the Raspberry Pi Pico. However, at one of the episode, he got trouble. Let me play his video.
Unfortunately, in the creation of this video, I actually bricked my Raspberry Pi Pico. I wired an LED in reverse and then grounded it to the board, and that actually fried the processor. So in the future, I will.
That's what he thought. Turned out that he forgot to put a loop, an infinite loop for the task of the the RTOS OS. As you can see here, he couldn't run it in debug mode. That's why he couldn't find this problem. So I was thinking, is there any better way to do so? So this is what I found.
Introducing the picoprobe. So basically, we just use another Pico board to drive the Pico board under test. And then we connect the SWD IO to the GPIO, and then the Pico A will drive the Pico B for everything, the deployment and then the testing as well. Let's try it. So we just need a VSCode IDE and run it. You can see that it has stopped at the main function. And then if we put a breakpoint here, let me run it. It will stop at the breakpoint, and then we can debug the C codes. You can see the next one, we will set the GPIO to the red LED to on, right? This is the expected LED. Let's try to run it. Let me continue the program. There you go. You can see it's on. Okay. And then the next command is to put the string output to the console. This is my console. And then let me run it and stop it right there. And basically it will go to the line 22 and turn the LED off. So let's see, we expect the LED to become off after it put the string to the console. Okay, let's run it. There you go. You can see it has an output on the console and also turn the LED off. Let's do it again. The next one is turn the LED on. and then run the line 25, which is goes to the console, and turn the LED off. It's cool, isn't it? So amazing. You can run it all over again. Very nice.
Just go directly to my repository on GitHub. That's the one for the picoprobe, right? And then start from this point. This is the repository for the Raspberry Pi Pico example. Okay. And then it has a link for the Pico SDK. You need to get it later, this one. Okay. The first link is the getting started with the Raspberry Pi Pico. Let's open it. This is a PDF document, and then go straight to the first appendix, which is page 58. That's the picoprobe. All right. So we need to set it up like this. So we need another Pico board to be the picoprobe to drive the picob here. You can see the picoprobe wiring. That's basically it's using the software data IO, this one, and then software clock and ground, those three pins for debugger. It goes to the Pico A GPIO2 and GPIO3. And of course, we need to also capture the console from the picob, which is the UART0 receiver and transmitter. So you can see this one goes to the GPIO4 and GPIO5. I'm using Windows 10 in this case, because I know that many hobbyists, they are using Windows. If you go back here, there is a way to install all of the Raspberry Pi Pico tools on Windows. First, you need the msys2, go there, and then install it using the installer. I think this is a lot of things. I'll make another video later for the Windows installation. Just follow this instruction and then also install the GCC. Go back here. Once you have the msys2, the ming.w, we can open the bash shell here. Make sure that we use the 64-bit version. And then we need to install all of those dependency and libraries. We need to build the openocd to talk to the pico probe. Okay, just follow this one. Clone the Git repository of the openocd. To the MSys. Make sure you open this one, the 64-bit version, right? And then I created a workspace on my home directory for Pico development. So when you clone the openocd, then you can go there. This one, openocd, and then just follow this one because we need the openocd to talk to the Pico port. So the chip is the RP 2040. Just follow this thing. And then make sure you can run the openocd. Once you're done with the openocd, you need to install the picoprobe app itself. So the picoprobe, you can build it yourself. Just get it from the GitHub repository, this one, and then follow this. Or you can get the pre-built from the Raspberry Pi website. Just follow this link. You follow this link, go to Raspberry Pi Pico. And then if you scroll down to the bottom, there is this section called debugging using another Raspberry Pi Pico. You can download the picoprobe.uf2. Just save it like this, right? And then next is install it to the Pico port itself. So just go ahead to do so. So the way to install the Pico app is you need to hold the boot select button, this one, while connecting the USB to the computer. Okay, let's do that. Okay, when you do that way, it will open the Raspberry Pico board as external media. And then what you need to do is just drag and drop. Let me find the picoprobe application here. And then Just drag and drop there. There you go. It's turned on. Okay. Now you need to find the COM port that used by the picoprobe. So just go to the control panel and then search for device manager. And you can see which communication port that is used by the picoprobe. In my case, it's a COM port 5. So to connect to this communication port, I use the PuTTY application. You can install it from here. You just get the link from my GitHub repository, get it there. And let's see. You go to the PuTTY application, open it, and then get the serial line 5. You can put this bit and open it. So it's going to be ready, right? And then after that, what you need is Visual Studio Code application. So go back to the getting started. Go to the page 39. That's on the tools needed to build on Microsoft Windows. So you need to install the ARM GNU toolchain because this is the cross compiler for Raspberry Pi Pico. Just download it. Download the exe installer and run it. And then you need cmake-tools. Just download it for Windows. This is the Windows installer. You can get the latest, but in my case, I'm using cmake 3.14. Okay. Another thing is you need Git, of course. And then you clone my repository. Just make sure you get this one. And then open it on Visual VSCode. So let me explain to you what I've done here. First, you need some extension to build on VSCode. So there is a cortex-debugger extension, cmake-tool extension, and cpp-tool extension. So if you get it from my repository, then it's automatically get it for you on the extension. Otherwise, you need to do it manually. That's the cortex debugger. And then the cmake-tools, of course. And the CPP tools. Okay. Go back here. And since we going to use the bash shell, the terminal a lot, so I also have a user setting here to add that msys min w64. This is the default location, right? You need to get that patch file, the CMD file. You need to refer to that openocd that we built before. For cmake, you need to generate the msys make files. The default is Unix make files. It won't work on the min w64. Okay, so if you have this, right? If you have this terminal, then you can open the terminal directly from the VS Code like this. Okay, let me rename this one. So I need to rename this. And then what we need is the msys min w64 terminal. And let me rename this one because we need to open the openocd server. That's the debugger server. Okay. And then we should be able to start our GDB server. This is the command. You make sure that you use the picoprobe configuration and the RP 2040 configuration. So let's do it. You can see that it's connected. Right? Okay. Since we have the debugger server running, we can try our application. I have the test.c, right? Oh, I need to tell you that actually I'm using the Raspberry Pico board from WaveShare. That is not standard. That it's a nice board. I like it. It comes with the LCD and it's already using the USB-C type. However, it doesn't have the LED connected to the GPIO 25. So in my test here, instead of the GPIO 25, I connected to the red LED on the GPIO 0. Check the schematic. Oh, actually that's the GPIO 2 instead. Okay. Okay. All right. So we need to build this. Let's open another one for the GNU debugger. Open another one. This one. I'm going to use the GNU debugger multi-arch, right? And then make sure that you have the pico-sdk import cmake, this one. You can get it from the pico-sdk. So I already cloned it here. So if you see SDK external, you can get it from here. Copy it to our project directory. And then you need to set up several environment variables. That's the most important one is the location of the Pico SDK. And then what is the Pico platform? That's the Raspberry Pi 2040. And then also, let me see my list here. Oh, the Pico toolchain path. That's where we put the toolchain. This one. This is the default location for the ARM GNU toolchain location, right? So on Windows, so you go to the settings, and then you look for systems. Edit the system environment variables. So it will open the system properties. And then you go to the environment variables. Make sure you put those environment variables for the Pico SDK path and Pico toolchain path. Otherwise, you can do it on the current session using export command. like this for every single environment variable. Make sure that you have cmake. Okay. Let's build this one. All right. First step is create a build subfolder. And then you can go there and run cmake to configure our stuff. I just want to show you the cmake generator. Make sure that we use the this one, mc make files. Okay, cmake -g. So we are not using nmake, but we use mcs. And then make sure we build it in debug mode. So put the cmake build type debug, and then we put the dot here. Let's do it. All right, everything is good. Now you can see it generate the cmake cache.txt. Basically, that's the configuration of the cmake for our project build. Let's build it. I have plenty of core, so I can run it in 12 threads. So I put the make-j12 for 12 threads. Good. So we have this test.uf2, but in this case, we just need the ELF format. As we can see, the openocd is running on the port 3333. Okay. So let's try it with the GNU debugger with our test.elf. Right. And then make sure that we want to break on the main function. Right. And then we need to connect to the debugger server. In this case, is the openocd. Put this command: target remote local host port 3333. Good. So we can tell the picoprobe to load the binary. Nice. And then we can start the application. Continue, or sometimes I just put C. It will break at the main, since we already did put the breakpoint on the main function. And then you can disassembly that one, disassembly, right? As you can see, this is the main function, all right? And then we want to run this one, init, and then this one. We want to break on the line 25th. Let's put the breakpoint there. Assume the progress. There you go. You can see, right? The red LED is turned on, and then the next line is putting the string hello Ryan to the console. Let's see. And then it will break, and then it will go to the line 25th, 22nd, to turn off the LED, the red LED, and it will break on the line 25th again. Let's see. It's working, right? You can do it a couple times to make sure that it's working as expected. Let me put the breakpoint on the line 23 to check if we can turn off the red LED. There you go. So it turned off. And then if we continue, it will go to the line 25th and turn it on again, turn it off again, turn it on again, turn it off again. Nice. We can make it work with the GDB, the GNU Debugger. We want to do it on the VSCode. So press Ctrl C, and then we can quit. All right. And then the build directory, actually, we already have the cmake configuration. Somehow, the cmake-tools extension, I couldn't configure it right, so just use this one. And first, you need to make sure that we use the cross compiler, the ARM GNU toolchain. So let's press the Ctrl+Shift+P, and then we need to select a kit for the cmake, and then make sure that we don't use any of this compiler, because the default compiler are for the x86 architecture. So we want to use our ARM compiler instead. So make sure you select the unspecified. Okay. And then let's see if we can build on Visual VS Code. Wait, I need to explain our launch configuration. Okay. So our launch configuration will start cmake-tools to build our application. So we need to make sure that it could run. Control-Shift-B, and then it will start the cmake build on VS Code using the cmake-tools extension. Okay, it seems that it's working. Now we can take a look our launch configuration. Right. So this is our launch configuration. Basically, we need to tell our entry point is the main function, but this is a tweak to break on the main function, right? And then we need to connect to our openocd debug server, and we are using the gdb-multiarch tools, and then the device is this one. All right, let's see if it's working. Oh wait, let's put a breakpoint here. And then if we go to the run and debug, this is our launch configuration. Let's try again. Sometimes it ruined the cmake configuration. So just remove the whole build directory. And then start over again. Okay. And then build. Okay, looks good. 94%, 100%, and done. Okay, go back to here again, and then let's start. Now we can get the selection. We need to build the test.elf. Okay. After we're done with the GNU debugger, we want to do it on the Visual Studio Code, right? Because we need to do it on the IDE, and then we can put the breakpoint. Visually is very easier than the GNU debugger. In my Visual Studio Code launch configuration, Actually, I have two launch configuration. One is the picoprobe debug, and the other one is the pico debug. Pico debug actually will connect to the current OCD debugger server. That's why we need to connect to the correct GDB target, right? And then we're still using the gdb-multiarch to connect. And then, of course, we don't want to do that ritual all over again every time we want to debug. We have another debug configuration that actually start the openocd automatically. Okay, let's try the second one first, that connect to the external OCD server. Okay. As I mentioned before, we already set up all of those extension using the cmake-tools and also the CPP-tools. Let's try. The Pico debug is openocd still running. Let's start it. This looks good. It will start the build. There you go. It's working now. It's breaking on the main function. And then on the debugging window, actually, we can see all of those variables and register. If we want to check what is the value in those register, we have 13 register from the R0 until R12. Also the stack pointer, the LR, PC, program counter. This is very nice, so we don't need to keep typing and typing using the GNU debugger. As you can see, we put the breakpoint on the line 25 because it will come here and then turn off the LED first and turn it on. So let's run it. Continue. Hey, it's working. All right. Now we put the breakpoint here because this is a loop. It will go here, turn it off, and then stop on the line 23rd. Haha. Now the red LED is off. And then we want to turn it on and then stop on the line 45 again. It will put the string output to the console. See? It's working. Okay, let's do it again. Turn off the LED. Turn on the LED. And then put the new string. Haha, it's working. All right. Okay. So we know it's working. Let's try another launch configuration. Let me stop this one. Okay. And then go to the terminal. I need to stop the openocd. And then let's try the second option. I mean, the first option that start the openocd automatically from the VS Code. Looks good. Starting to compile. And then as you can see, start the gdb-server automatically. That's the openocd, and break on the main function. And then we want to break on the line 23rd. Basically, we cannot see the difference because it's just turned off the red LED. We want to turn it on. It's on. It's breaking there. And then we want to spit out the string output to the console. There we go. Now everything is working. So we can use this same configuration for the more advanced or more complex application. Let's say with the real-time OS, because we need to take care of a lot of things on that one. So as usual, if you like it, please share and subscribe to the channel. Thank you. Bye-bye.